Hello everyone, so today we'll be looking at Form 4 Chapter 4, the periodic table of elements, and specifically we'll be focusing on Group 18 Elements. So a short recap session before we start our lesson. We have learned that in the periodic table of elements, the elements are arranged in ascending order of proton number from the left to the right, from the left to the right, and from the left to the right. And we have learned that the periodic table of elements consists of groups and periods, whereby the groups are represented by the vertical columns and the periods are represented by the horizontal rows. And the group is determined by the number of valence electron, while the period is determined by the number of shells occupied by electrons, right? And we've also gone through the overview of the chapter of what we're going to learn about in this chapter, whereby we're going to learn about the physical properties of the elements, which are the observable properties of the elements, and we're also going to learn about the chemical properties of the elements, which are the reactions of these elements with other substances, right? And in terms of physical properties, we're going to learn about the appearance of the elements, the conductivity of the elements, density, solubility, hardness for solids, and also the melting and boiling points. And in general, for conductivity, we're going to learn about the conductivity in terms of heat and electricity. And in general, metals are good conductors, while non-metals are bad conductors, which makes them good insulators of heat and electricity. And in terms of density, metals tend to have a high density, while non-metals tend to have a low density. And in terms of melting and boiling points, non-metals usually have low melting and boiling points, while metals have high melting and boiling points. And the difference in melting and boiling points is due to the differences in the forces of attraction, whereby non-metals are held together by weak van der Waals forces of attraction, while metals are held together by strong metallic bonds. This is why non-metals have a lower melting and boiling point, because they are held by weak van der Waals force of attraction, while metals have a higher melting and boiling point because of the strong metallic bonds. However, if we're comparing between non-metals with non-metals, then as the size of the non-metals increase, then the forces of attraction, the weak van der Waals force of attraction, will increase, and therefore more heat will be required to overcome the force of attraction between the non-metals. Therefore, as the non-metal size increases, the melting and boiling point will increase. It is the opposite of one another. So since it is weak, when the size increases, the force of attraction will increase. But for metals, when the size of the metals increase, the forces of attraction will actually decrease. Strong, decrease is the opposite. Weak, increase. Strong, decrease. And when the forces of attraction between the metals decrease, then there will be less heat that is required to overcome those forces of attraction. Therefore, when the size of the metal increases, the melting and boiling point will decrease. And this is because the forces of attraction will decrease. And then when we look at the chemical properties of the elements, we're talking about the reactions of the elements with other substances. And the difference in reactivity of elements can be explained by the electron arrangement. So if the electron arrangement is octet or duplet, meaning that it is stable. So if it has achieved stable octet or stable duplet electron arrangement, then it is unreactive. However, if the electron arrangement is not octet or not duplet, then it is unstable. If it is unstable, it wants to be stable. It wants to achieve stable electron arrangement. Either it is octet or duplet. Therefore, it has to receive or release electrons, right? So in order to receive or release electrons, it has to react with other substances. Therefore, it makes it reactive. And when we're comparing between the reactivity down the groups, we often use two terms known as electropositivity and also electronegativity. Electropositivity is the tendency of an atom to donate valence electron to achieve stable electron arrangement to become a cation. A cation is a positively charged ion, right? T. So that explains why it is known as electropositivity. You form a positive ion with the release of an electron. For electronegativity is the tendency of an atom to accept electron to achieve stable electron arrangement and become an anion. Anion refers to negatively charged ion. This explains the word electronegativity, right? Negativity referring to negative ion, electro referring to accepting electron. So that was a short overview of what we have learned in the last video. So now that we have gone through a short recap session of what we have learned in the previous video, let's attempt a few questions to strengthen our understanding of the chapter before we go deeper into what we're actually going to learn for today's lesson, right? So to those who would like to try the questions before I start explaining, you can pause the video now and I will start explaining in 3, 2, 1. Alright, so the table below shows the number of neutrons and the nuclear number for elements X and Y, right? So we're given element X and Y, and the neutron number for X is 10, while the nuclear number is 19. Element Y has a neutron number of 18 and nuclear number of 35. And the first question that they give us is, write the electron arrangement for element X. So in order to obtain the electron arrangement, we need to know the number of electrons, right? We need to know the number of electrons. And the number of electrons is equal to the number of protons for atoms, right? Number of protons. So in this case, we're not given the proton number. We're given the neutron number and also the nucleon number. However, since we know, based on our knowledge from chapter 2, right, the nucleon number is actually equal to the sum of the number of protons and the number of neutrons, right? So we are able to find the number of protons, right? We know that the number of the neutron number, the nuclear number, right? The nuclear number is equal to the proton number plus the neutron number. Therefore, the proton number is equal to the nuclear number minus the neutron number, because the nucleus is made up of protons and neutrons. So if we have the total number of protons and neutrons in the nucleus, which is the nuclear number, and we have the neutron number, then we are able to find the proton number by subtracting the neutron number from the nuclear number, right? So the proton number of element X is equal to 19 minus 10, which is equal to 9, right? So the electron arrangement for element X will be equal to 2, 7, right? We have 9 electrons, and we know that the first shell has 2 electrons, so 9 minus 2 is 7. So the electron arrangement for element X is 2, 7. Now, question B. Question B asks us to state the position of element X and element Y in the periodic table. So since we already have the electron arrangement for element X, let's state the position of element X before we do element Y. So from the electron arrangement for element X, we know that it has 2 shells that are occupied by electrons, meaning it is in period 2, and we know that the valence electron is 7. But since we know from the previous video's lesson, we know that if the valence electron is more than 2, we have to add 10 to find the group, right? So it is group 17, and 2 shells occupied by electrons, meaning it is period 2. So element X is in group 17, period 2. Now, how about element Y? So element Y, we have the nuclear number and also the neutron number. So first, same thing, we have to find the proton number, right? Proton number is equal to 35 minus 18, which is equal to 17, right? 17. So this is also the number of electrons for element Y, and the electron arrangement for Y is going to be equal to 287. So since the valence electron is also 7, it's also in group 17, and it has 3 shells that are occupied by electrons. Therefore, it is in period 3. Right? Period 3. And then question C. Do both of the elements have the same chemical properties? Why? Alright, so if we look at the valence electrons of both of the elements, we'll notice that they have the same number of valence electrons, which means that they are also in the same group. And as you know, all the elements that are in the same group have the same number of valence electrons. And if you actually think about it, right, what we've learned in chapter 2, elements with the same number of valence electrons will show similar chemical properties. And this is actually why we group the elements in groups and periods, right? So all elements in the same group, actually have the same similar chemical properties. And this is because of the number of valence electrons. So do both of the elements have the same chemical properties? Well, yes, because looking at the electron arrangement, or even looking at the group of the elements, we know that yes, it does have the same chemical properties. And this is because they have the same number of valence electrons. So if this question comes out in your examination, you will know how to answer it. Right, so now that we have gone through a short recap session and we've also attempted a few questions, now we'll be looking at the actual focus of today's topic, which is the group 18 elements. Right, so group 18 elements, a special characteristic that only group 18 elements have is that group 18 elements are the only gases that exist as monoatoms. They are the only monoatomic gases, right? So for example, helium exists as just helium, right? He. However, if you compare with other gases such as oxygen, nitrogen, right, they exist as diatoms. They are diatomic gases. They exist as 2 atoms, right? But for group 18 elements, they exist as one atom, just one atom. And we'll discuss why they exist as monoatomic gases later on. Now, monoatomic gases, group 18 elements are also referred to or known as inert gases and also noble gases. So if in your examinations you encounter the words inert gases or noble gases, they are referring to group 18 elements. They are the same. You can say inert gases, you can say noble gases, you can say group 18 elements. All of them refer to the same thing. So why are they called inert gases, right? Because if you look at the dictionary, inert means chemically unreactive, right? They are unreactive. So that is why they are called inert gases. Group 18 elements are called inert gases because they are unreactive. But why are they unreactive? So if we go back to the overview of the chapter, right, we'll know that if they are unreactive, it means that they have achieved stable octet or duplet electron arrangement, right? If the electron arrangement is stable octet or duplet electron arrangement, then the element is unreactive. But if the electron arrangement is not octet or duplet, then it is unstable, which causes it to be reactive, right? And this is because if it did not achieve stable electron arrangement yet, it will want to release or receive electrons from other elements in order to achieve stable electron arrangement, So in order to do that, it must react with other substances, right? Other elements. However, in the case of group 18 elements, right, they are unreactive because they already achieve stable electron arrangement. Achieve stable electron arrangement. For example, let's take helium as an example, right? Helium has 2 protons, right? 2 protons, which means it has 2 electrons, and therefore the electron arrangement is 2, right? So helium has achieved stable duplet electron arrangement, while the other elements in group 18 has already achieved stable octet electron arrangement. Therefore, they do not need to receive or release electrons in order to achieve stable electron arrangement, because they have already achieved stable electron arrangement, right? So they are very stable. Very stable. Thus, they are unreactive. This is also why they exist as monoatomic gases, because they have already achieved stable electron arrangement. They do not need to bond with each other to achieve stable electron arrangement. In the case of oxygen, for example, they need to bond with each other in order to achieve stable electron arrangement. Now, what about elements which are reactive, right? We say that elements that are unreactive, they have already achieved stable electron arrangement, and we know that the ones with not unstable electron arrangements are reactive. So why do we say they're reactive, and how does it actually work out, right? So let's say we have an element from group 1. Let's say we have an element from group 1, which is sodium, right? So sodium, and then let's say we have another element from group 17. Let's say we have chlorine. And so these elements, right, they are not from group 18, which means they are reactive. And they are reactive because they have not achieved stable electron arrangement. For example, let's say sodium, right? Sodium, the electron arrangement is going to be 281, right? Because it has 11 protons, therefore it has 11 electrons, and it has so it's going to be 281, right? The electron arrangement is going to be 281. So in order to achieve electron arrangement of 28, right, it has to release one electron. It has to release one of its valence electrons in order to achieve stable octet electron arrangement and become a cation, which is Na+. On the other hand, we have chlorine. Chlorine, the electron arrangement is going to be 287, right? Because it has 17 protons, which means it has 17 electrons, and so the electron arrangement is 287. In the case of chlorine, if it wants to achieve a stable octet electron arrangement, which is 28, it has to receive, which is 288, it has to receive one electron to fully occupy its last shell, which is the third shell, in order to obtain the electron arrangement of 288 to become Cl-. So since sodium needs to release one electron, right, where does this one electron go? And when you think about it, chlorine, it has to receive one electron. Where does this electron come from? So the transfer of electrons from one element to another element is what happens here. So sodium will release one electron, and this one electron will actually be received by chlorine. That is why we say that elements with an unstable electron arrangement that have not achieved a stable electron arrangement are reactive, because they have to release and receive electrons to achieve stable electron arrangement. And in order to do that, one element or one atom or one compound or one substance must release electron, while the other receives those electrons. So in this case, sodium, Na, releases an electron, and this one electron is received by chlorine. So this is a reaction. This is a reaction, right? Whereby Na will react with chlorine gas to form NaCl, sodium chloride, and then you balance the equation. So this does not happen with the group 18 elements because they've already achieved stable octet or stable duplet electron arrangement. So they do not need to receive or release electrons to or react with other substances in order to achieve it because they have already achieved it. Next, let's look at the physical properties and the comparison of the group 18 elements going down the group. So in terms of physical properties, we're going to look at the appearance, conductivity, density, solubility, and the melting and boiling point. So the appearance of the group 18 elements. So the group 18 elements, right, they exist as gases, right? They exist as monoatomic gases. And they are colorless gases. They are colorless gases. Some gases, which we will learn later on, are colorful gases. They have color. Different gases may have different colors, but group 18 elements, they exist as colorless gases. How about conductivity? So group 18 elements, they are non-metals, right? They are gases, they are non-metals. And since they are non-metals, they have bad conductivity of heat and electricity. Okay, and next, density. Again, it is a non-metal, so it is low. It has low density. How about solubility? Solubility. In terms of solubility, it is insoluble in water. How about its melting and boiling point? Well, as we already mentioned earlier, it is non-metal, and non-metals are held together by weak van der Waals forces of attraction, right? They are held together by weak van der Waals forces of attraction. Therefore, they have low melting and boiling points. Okay. Next, we're going to look at the comparison between the elements in this group when we go down the group, right? When we're going down the group. So we're going to look at two things, which is the atomic size and also the melting and boiling point. So for the atomic size, when we're going down the group, the atomic size will actually increase. Okay, it will increase. Why will it increase? Okay, so let's say we have helium, right? We have helium, so the electron arrangement is going to be 2. And then let's say we have neon, right? Neon, it has 10 electrons, right? Because it has 10 protons. 10 protons equals to 10 electrons. Therefore, the electron arrangement is going to be 2, 8. So let's try drawing these, right? Let's try drawing it. So we have helium with 2 electrons. So this is how you would draw the electron arrangement. Next, you have neon, right? Neon. And then you have two electrons in the innermost shell, and you have 8 electrons on the second, which is also the outermost shell. So if you compare between helium and neon, you can see that the atomic radius of helium, right, is smaller than the atomic radius of neon, right? We can say that the atomic size increases because the atomic radius increases going down the group, and this is because the number of shells occupied by electrons increase, right? Helium has 1 shell because it is in period 1. Neon has 2 shells, so it is in because it is in period 2. Then you have argon with 3 shells, krypton with 4 shells, xenon with 5 shells. And when the number of shells occupied by electrons increase, the atomic radius will also increase, right? The atomic radius will increase. Therefore, the atomic size will increase. Very simple, right? Next, let's talk about the melting and boiling point. So we know that the group 18 elements, they are non-metals, right? Group 18 elements are non-metals. and because they are non-metals, they are held together by weak van der Waals forces of attraction. And we know that when the atomic size increases, the forces of attraction will increase, right? Let's go back to the overview, right? We know that for non-metals, the force of attraction is weak van der Waals forces of attraction. And when the size increases, the forces of attraction will increase, and the amount of heat required to overcome the force of attraction will also increase. So in this case, right, for group 18 elements, when going down the group, right, the atomic size increases. Therefore, the van der Waals forces of attraction will also increase. Thus, more heat is required to overcome the forces of attraction, and therefore melting and boiling point increases going down the group. So that would be the comparison of the elements going down the group. Next, we will be looking at the uses of a group 18 elements. Okay, we'll be looking at the uses of a group 18 elements. So each of these elements, they have a specific uses. They have specific uses. So for example, helium. Helium is used to make weather balloons. Weather balloons, right? We often see like and the reason that helium is used as weather balloons is because they are light. But of course, you can argue that hydrogen should be lighter than helium, right? Hydrogen is definitely lighter than helium. But why is helium used instead of hydrogen in weather balloons and so on? The reason is helium, even though it's less light, but it is inert. It is unreactive. So because it is unreactive, that is why we use helium instead of hydrogen. Of course, yes, hydrogen is lighter than helium, and it would make sense to use hydrogen, but hydrogen is reactive, right? Because it did not achieve stable electron arrangement, which is why we use helium, because helium is the second lightest element and it is unreactive. So we use it in weather balloons. And other than weather balloons, we also use helium to fill the oxygen tanks that are used by divers. Right, now how about neon? Neon is used for the neon lights used for advertising boards and billboards. For advertising boards, right? We often hear of neon lights, the bright lights that you always see that people use for advertising boards, billboards, and so on. Now, how about argon? I'm not sure whether all of you have already learned this for physics, but argon is actually one of the gases that is used to fill the filament bulbs. So if you don't know what a filament bulb is, it's something like that. Yeah, something like that. So inside of the bulb, you actually fill argon gas. And then, other than filling argon gas, you also provide argon gas is also used to provide an inert atmosphere for welding. Okay, and then after argon, let's look at krypton. So krypton, it has two main uses that are highlighted in your syllabus. Number one, it is used for high-speed flash bulbs. So this is used in cameras. So I don't know if you have ever seen a camera, right? So usually on top of the camera you have a flash bulb, right? The flash bulb. So in the flash bulb you use krypton. Other than flash bulbs, krypton is also used in laser treatment. Laser treatment for retina of the eye. And then you have xenon. What is xenon used for? Xenon is used for fluorescent lamps or fluorescent lights. Yeah, fluorescent lights. And xenon is also used in anesthesia. So if you've ever seen like patients in the hospitals, if you're going to do surgery or something, you want to minimize the pain felt by the patient, and you would usually inject anesthesia, or you would have the patient breathe in anesthesia gas. So in the anesthesia gas, you actually use xenon. Finally, you have radon. So radon, it is used for radiotherapy, for cancer treatment. I think for radon is quite easy to remember because the name itself, radon, is quite easy for you to remember radon as a radiation. And when you think of radiation, you think of radiotherapy for cancer treatment, right? So those were the uses of group 18 elements. So for helium, helium is used to make weather balloons and also to fill oxygen tanks in divers. And neon is used for neon lights for advertising boards. Argon is used to fill filament bulbs and to provide an inert atmosphere for welding. Krypton is used for high-speed flash bulbs in cameras for photography and also laser treatment for the retina of the eye. Xenon is used for fluorescent lights and anesthesia. And radon is used for radiotherapy for cancer treatment. Now, let's have a short little exercise in order to strengthen our memory of the uses of group 18 elements. So what do we have here? So the first thing that we have here is neon lights, right? So neon lights, the gas that you use to make neon lights is, of course, neon. Right. Next, you have this, which is the flash bulb that is usually placed on cameras for photography. So for this, you actually use krypton. Oh, and for anyone who would like to attempt the following questions, you can actually pause the video before I attempt it, right? Okay, so I'll continue in 3, 2, 1. All right, so next you have a picture of a diver with an oxygen tank. So in oxygen tanks, you usually use helium, right? You use helium. Right, next there's a picture of fluorescent lights. So for fluorescent lights, you use xenon gas, right? Xenon gas. Okay, next you have anesthesia gas, right? You have a photo of a patient and they are inserting anesthesia gas into for the patient to breathe in. So for anesthesia gas, you actually use xenon as well. Right. Now, next we have a photo of a helium balloon, right? A weather balloon. So for a weather balloon, you usually use helium gas. Next is a photo of a person welding, right? It's welding. So for welding, you use argon gas. And then a photo of a filament bulb. So in the bulb, right? In the bulb, you fill it with argon gas. So this will be the answer. Okay, next you have what seems to be eye laser treatment on the retina. So you use krypton gas. Next, you have a photo of a radiotherapy, right? Radiotherapy for cancer treatment. So of course that would be using radon. Right, radon radiotherapy, radiation, yeah. Okay. Last, we have two questions here, right? Why is helium unreactive? So if this question is asked in the examination, how should you answer it? Well, first you need to know that helium is a group 18 element, and all group 18 elements are unreactive. However, some group 18 elements have a stable duplet electron arrangement, while others have a stable octet electron arrangement, right? For helium, helium is the only element in group 18 that achieves stable duplet electron arrangement. Every other element has achieved stable octet electron arrangement. So the answer for why helium is unreactive is that helium has achieved stable duplet electron arrangement. Next, the final question before we wrap all of this up is what happens to the melting points of noble gases, which are group 18 elements, going down the group. Okay, so going down the group, we know that the atomic size increases. Therefore, when the atomic size increases, since group 18 elements or noble gases or inert gases are non-metals, they are held together by weak van der Waals forces of attraction, right? So therefore, when the atomic size increases, the van der Waals forces of attraction will increase, and when the van der Waals forces of attraction increase, more heat will be required to overcome the forces of attraction. Thus, the melting point of the noble gases will increase. Right, so that is all for today's lesson, right? So let us recap what we have learned. We have learned that the group 18 elements are the only elements that exist as monoatomic gases compared to other gases which are diatomic. And group 18 elements are also known as inert gases or noble gases, and they are known as inert gases because they are unreactive, and this is because they have achieved stable electron arrangement, where helium has achieved a stable duplet electron arrangement, while the other have achieved stable octet electron arrangement. This is opposed to other elements which are reactive because they have not achieved stable electron arrangement. Therefore, they are required to release or receive electrons in order to achieve stable electron arrangement. And therefore, since they have to release or receive electrons, they require they are required to react with other substances in order to receive or release those electrons, right? For example, in here we have given the example of sodium and chloride, whereby sodium will release one electron and this electron will be received by chlorine. And then we have learned the physical properties of group 18 elements, whereby they are colorless gases, they are bad conductors of heat and electricity because they are non-metals, and they have low density because they are non-metals, and they are insoluble in water, and they have low melting and boiling points, and this is because they are non-metals. Therefore, they are held together by weak van der Waals forces of attraction, right? And then we have gone through the comparison of the group 18 elements going down the group, whereby when you go down the group, the atomic size increases, and this is because the atomic radius increases. And the atomic radius increases because the number of shells occupied by the electrons increase. For example, we have drawn the electron arrangement of helium and neon, right? Whereby if we compare between the electron arrangement of helium and neon has 2 shells occupied by electrons, while helium has only 1 shell occupied by electrons. And neon, because of that, neon has a larger atomic radius compared to helium. Thus, the atomic size increases. And because the atomic size increases, the melting and boiling points will also increase. And this is because, again, they are nonmetals that are held together by weak van der Waals forces of attraction. Therefore, when the atomic size increase, the van der Waals force of attraction will also increase. And thus, more heat will be required to overcome the forces of attraction, leading to an increase in melting and boiling point. And we have also learned the uses of group 18 elements, right? And that is all for today's lesson. Thank you very much, and I hope that all of you were able to understand what was taught in this video. Thank you and bye-bye.